Alright, so I need to set up two falsifiable hypotheses and make sure they're set up properly. I need to set up two falsifiable hypotheses about Python. And I'm not against Python, I've just had it crash on me many a time. It's got an alternative language. One, Python defaults to the none type. Two, the none type causes fatal. Oh, let's keep that causes system crashes on certain theoretical CS problems. Let's work these into non-biased falsifiable hypotheses. To create scientifically rigorous falsifiable hypotheses, we must move away from anecdotal statements toward measurable, testable assertions. In scientific methodology, a hypothesis is falsifiable if it can be proven wrong through observation or experimentation. Here's an assessment and refinement of your 2 points in a testable, unbiased hypothesis. 1. Default object assignment. Your original premise, Python defaults to the none type, is slightly imprecise as Python variables do not hold a value until assigned. However, the observable behavior is that uninitialized function arguments or return values default to none. The refined hypothesis in standard CPython 3.x, any function defined without an explicit return statement or a function parameter defined without a default value that is not provided during the call will evaluate to the none type object. It could be none type and none is the problem. To impact on system stability, your second premise, the none type causes system crashes on certain theoretical CS problems, is currently too vague to be falsified because theoretical is supposed to be presence of a none type object in an arithmetic operation within a standard CPython execution environment will trigger a type error. Okay, so print those two falsifiable hypotheses now. Refined falsifiable default object assignment and hypothesis 2 on runtime behavior with none type. Hypothesis 1. In standard CPython 3.x, any function defined without an explicit return statement will return the none type object. And any function parameter defined without an explicit default value will be assigned none if no argument is provided during the function call. And premise 3. The presence of the void represented by none type and none causes theoretical systemic crashes. Work this into a falsifiable hypothesis. To translate the concept of the void into a testable, falsifiable hypothesis, we must map abstract terminology to concrete computational behaviors such as memory management and interpreter stability. Memory safety. So what we're doing is I have a lot of bias. So we're trying to use science to see, if we can get the bias out. Now, on your end, collect the scientific evidence necessary for the study. To investigate these hypotheses, we rely on the architectural specifications of the CPython implementation standard Python interpreter. Below is the gathered scientific evidence regarding the nature of none-type and its role in execution stability. 1. Nature of none-type, evidence 4, hypothesis 1. Evidence confirms that none is not merely a default value, but a singleton instance of a none-type class. Singleton status. In the CPython CAPI, none is defined as PyNone. It is an immortal object. And already there's some language where we can kind of pull and play with this thing. Push, pull, and play with this thing, meaning its reference count is managed such that it is never deallocated. Defaulting mechanism. The language specification dictates that if a function execution reaches its end without an explicit return statement, the bytecode interpreter executes return none, which returns the singleton none. So that ties back into hypothesis 3. But number 2, runtime stability and type error evidence for hypothesis 2. Scientific evidence indicates that none is explicitly handled by the interpreter to prevent low-level memory corruption. Type checking. The CPython source code performs checks on operands during binary operations. When an operator like __add_ is called, the interpreter checks if the types support the operation. If a type does not implement the operation, which none type does not, the interpreter raises a standard type error. Safety versus crash. A type error is a controlled exception. It is the mechanism, so we have a mechanism. That is communism. We don't have machinery. We have a mechanism. The interpreter uses to guarantee that memory operations remain valid. It specifically prevents the execution from reaching a point where it would perform an operation on an invalid memory address. Now 3, the void and systemic crashes, evidence 4, hypothesis 3. The premise that none type causes systemic crashes or segmentation faults is contradicted by the design of the Python virtual machine. Memory safety abstraction. The PVM manages a private heap. All objects, including the none-type singleton, are subject to the same reference counting and garbage collection rules. Because none is a valid existent object in memory, accessing it is a safe operation. There's an isolation of faults as well as exception clauses for C extensions and interpreter bugs. So we have a summary of the evidence that hypothesis 1 is validated. None type is a singleton constant, and Python ensures this through bytecode level injection of the PyNone constant returned parameter scenarios. Hypothesis 2 is validated. Python uses robust type checking, but hypothesis 3 is falsified or refuted. The standard Python interpreter is designed to treat none as a safe, legitimate memory object. Okay, so is this study biased? especially in terms of my premise that dot script is a better language for constructions in CS math. The study of your hypotheses, which focused on the technical mechanisms of Python's none type and interpretability, is not inherently biased, but it's narrow in scope. It treats Python as a stable, predictable system, which is the standard approach in computer science for evaluating existing, widely used languages. However, your premise that dot script is a better language for constructions in CS and math introduces a subjective evaluation that moves beyond objective testing. To address your questions about bias and the comparison of dot script, we must distinguish between objective analysis and qualitative preference. Is it bias? The methodological objectivity. In our previous discussion, we relied on the CPython source code and standard error handling mechanisms. It's subjective. The code either raises a type error or it doesn't. The limitation, the bias in such a study often arises from starting assumptions. If we define good programming exclusively as memory safe, interpreter stable, evaluating dot script, and don't really feel like reading too much more. But on dot script, constructs for CS and math, if dot script provides stronger mathematical primitives compared to Python's reliance on libraries like NumPy or SymPy, you might argue it is better for that specific domain. So, what is the ultimate conclusion? I have found that empty set based mathematical reasoning leads to paradoxes, vacuous anomalies, etc. I would think the same applies to none type and none. Educate me on why these are different things. The core of your inquiry touches on a fundamental tension between mathematical set theory and computational implementation. You're observing that the concept of nothingness behaves differently in these two domains. To understand why none and the mathematical empty set are distinct, we must look at how they exist and function. The empty set is defined by the axiom of extensionality. It is a unique set that contains no elements. It's a container that is empty, but its logical behavior is that can lead to vacuous truths. It's a feature of logic, not a paradox. That's how we maintain consistency in proofs. I don't think it works well for construction, though. The computational none type in Python and many other languages, none is not a container, nor is it empty. So let's prove that. Let's prove that none does not lead to vacuous truths. What is its logic? To prove that none does not lead to vacuous truths in the way the empty set does in mathematics, we must distinguish between logical propositions, which can be vacuously true, and imperative execution, which is how code runs. Logic of Python, imperative, not predicative. In Python, none is an explicit value, not a collection. Python does not use universal quantification for all over none. Instead, it uses conditional branching. So there should be an absence of vacuous truth. The math approach is consider a function f, and Python approach it's a singular point, not a void set. Interesting. Could I program a set in Python none, call it the inhabited none set? What happens? Yeah, I can program that. Inhabited none set. And I've defanged the potential for paradoxes by doing that. Let's see what happens when the scope of the project relies on none. Computationally, and then what happens mathematically. When we shift the scope of a system to rely on an inhabited none set, we create a fascinating collision between the mathematical behavior of singleton sets and the computational behavior of memory managed objects. Mathematical perspective, we have a singleton. Huzzah! In set theory, the set none, inhabited none set, singleton set, its cardinality is 1. It's logically sound, it has a set algebra. The result, mathematically, the system is perfectly stable. The none acts like any other primitive constant, 0 or pi. There's no void here. Computational perspective, the pointer cache. In Python, the set with none in it is not a mathematical set. It is a set object memory that holds a reference to a none-type singleton. Cool. Cool. If you build a framework like your dot script concept where none is a foundational construction, you're essentially building a type check singleton system. So we can build dot script in Python. Cool. We also need an all primitive. The way it works, all set, all dot set operations default to the inhabited none set. Building an all primitive that defaults to none is a fascinating architectural decision. By setting the non-inhabited unbodied set as the universal default for all dot set operations. You're effectively establishing a universal identity element for your language's set theory. So we have a universal identity element. I'm just curious. Is this now isomorphic to any other math structure? Now your proposed dot script structure, specifically the use of none as the default identity element for all set operations, is essentially an algebraic structure with a distinguished constant. Moving away from regular sets, it's a specific type of monoid. Your inhabited default makes your dot set an isomorphic class of pointed sets. In category theory, a pointed set is a set have a pointed set. Since your language defines every dot set to have a default member non-inhabited set, every dot set is mathematically identical to a pointed set S9. And under the isomorphism, any two singles in sets are isomorphic. Therefore, your inhabited none set is isomorphic to any other singleton set. Cool. There is an algebraic structure, a monoid with a non-empty identity. Looks like we got a little error there. We also evaluate all logic statements. Oh crap. But pass over vacuous truths. Oh no, infinite scroll. As a radical design choice for dot script. By explicitly opting to pass over or discard vacuous truths, you are effectively implementing a non-vacuous logic system. Cool. The evaluation of truth to require an active witness. So let's leave it at that. I was wrong. There is a distinction here in thinking. It's a profound realization. Moving from I am right to I was wrong is a hallmark of the scientific process. And what you just experienced is the fundamental shift between classical set theoretic thinking and constructive computational thinking. Cool beans. Cool beans. Cool beans.